today's session. In this session, we are going to discuss how to analyze a given truss by using the method of joints. Here we are going to solve a problem, but we are going to solve how to proceed the problems to solve for analyzing the given truss. We are not going to solve whole thing. How to approach for the given one. First, before solving the truss, that means we are going to find the internal numbers. Internal numbers means first of all the truss. We have general assumption is the loads are acting only at the joints. Now the given truss is 3 meter plus 6 meter plus 3 meter in the bottom, totally 12 meter, and the material height is 3 meter, and from here to here it is 6 meter. Like that, a triangular shape structural point of view, the truss is given, and the loads acting are at this joint at this time both are 50 kN. Let's take a point like A. Let's take this A, B, C, and D. Then we can go for this one E, F. Okay, so all the joints being given, there is notations. Okay, now how to approach? First, we should ensure that the truss is purely perfect or not. Only perfect truss can be solved by using method of joints. If it's not perfect, it is unable to solve or it is unable to find the internal numbers in the truss. So we should ensure the equilibrium condition. Otherwise, go for a perfect truss or not. That means whether m is equal to 2j minus 3. Whether we can have this kind of empirical relation to be satisfied. Okay, let's take first the number of members. How many members are there here? Let's take 1, 2, 3, 4, 5, 6, 7, 8, then 9. So the first being given is for members. So number of members is 9. What are the number of joints? Let's take 1. This is 2. This is 3. This is 4. This is 5. This is 6. So number of joints, totally 6 joints. Okay. Now just apply here. M is equal to 2j minus 3 or not. So what about 2j minus 3? 2 into j. J is 6 minus 3. So 12 minus 3, that is equal to 9. So what about m? M equal to 9. So both are satisfied. So it is a perfect truss. So we should ensure. Okay. Then only we can have the approach to proceed for finding the internal numbers in the given truss. Okay. Next, how to approach? So we should find what is the support reactions. Support reactions should be found out. So here the support is being given. It is a RA vertical reaction. Here is vertical reaction RD. Okay. So sum of vertical force equal to 0. RA plus RD, that is equal to 50 plus 50. So total is 100 Newton. 100. But we can say that it is a symmetrical one. How can it be symmetrical? We just have this one. This is 3 meter, it is also 3 meter, and it is also the same. It is a rectangular one. So rectangle is 70. You just make a cut here. Like a cut. The left and the right both are mirror image, similar. So you do not go for this kind of thing. Simply I can say that since it is similar or symmetrical, since it is symmetrical, RE is equal to RD. That means the total loads can be distributed equally. Because here also 50, here also 50. So if the loads are same, so I can say that the RE and RD, both supports will distribute or will take over the loads equally. That is also 50 kN. Otherwise, you can use sigma m about a particular point is equal to 0. That kind of method also you can use it. finally you can get the reaction like this. Okay, after finding the reaction, okay, after finding the reaction, you just go for method of joint approach. So first we have to identify a joint. We have to identify a joint. Which joint I can, otherwise I have to choose first. Okay, so you can choose A or B or C or D. Any joint you can choose, but at the same time the number of unknowns must be or should not be greater than 2, because we have equilibrium equation only we are going to apply. Here we are going to apply for method of joints only sigma B is equal to 0 or sigma H is equal to 0, where sigma B is equal to number of all vertical forces, only vertical forces, as well as number of horizontal forces, both are equal to 0. So only two equations. So number of joints, let's choose at the time the unknown members, number of unknown members should not be greater than 2. Like that can go. Let's take A. A joint A, I am having a member here. Just I have a 4 quadrant and I can put. For joint A, this load RA that is equal to 50 kilonewton. 50 kilonewton. Okay? So 50 kilonewton, it is directly associated to, so it's a joint A. So this point is A point. Here it is RB that is equal to 50 kilonewton. This is a node value. And here from A I can have a member AB as well as AF. So AB is purely horizontal. So observe force, internal force A, B, and the other one is an inclined member AF. That's an inclined member. Okay. And no other internal members or no other members are directly associated with the A. So only 3 things out of 3 I have this force is known. So only 2 unknowns. So I can choose this one. Okay. If you go for directly, if you are going to joint C, okay, in joint C you are having a member 1, 2, 3, 4. So directly it is associated with the 4 members. All are unknown values. All are unknown. So you cannot able to find all the numbers once you are selecting joint C directly as the first one. Okay. So choosing joint is very very important. How to approach that thing is you have to understand the joint should not have more than or not greater than 2 unknowns. Okay. I can't able to choose. Then what about the inclination here? Okay. Since it is a right angle triangle. But triangle is not given, but we have this AB is 3 meter and this is BF also 3 meter. What about this angle? Theta. So this theta to be found out, how to find? We can have a Taylor's theorem. This is opposite, this is adjacent. Opposite by adjacent is equal to tan theta. So tan theta equal to opposite side by adjacent side, that is 3 by 3, that is equal to 1. So tan theta equal to 1, then theta equal to tan inverse of 1, that is equal to 45 degree. Okay, 45 degree. After finding this one, since it is symmetrical, this is also 45 degree. Okay, like that you can choose. Then how to proceed? Use sigma v is equal to 0. Now sigma v is equal to 0. I just take right towards, that means towards right is positive, towards down is, towards left is negative for sigma h. For vertical force, towards upward and downward. Upward is taken as positive, 4 quadrants. Okay, and towards downward is negative. And I have this is 50 towards upward. So in this it is 50, and this is towards upward. So this is also positive F A F. And only 2 things are there. This is really horizontal. That is equal to 0. What about F A F? The member force equal to minus 50, and the unit is equal. Okay, F A F equal to minus 50 kilonewton. Then you can go for F A B. How to find? So you can use another thing. Sigma h is equal to 0. Okay, sigma h. Sum of all horizontal forces are equal to 0, sign convention towards horizontal is positive. That is horizontal. Okay. So FAB is equal to positive. And this is towards upward. So horizontal force is 0. But it is an inclined force. The angle of inclination 45 degree. And if how it fall down, the arrow is towards this side. So it will fall down like this. Then the arrow goes towards right side. So it is also positive. So this is FAF cos 45. That is equal to 0. So I know that this FAB equal to minus 50. This known value. So cos 45 value comes, and you can find what is FAF you know. FAF you know. So FAB is equal to minus FAF cos 45. So this is minus 50. Minus of minus plus. So that is equal to 50 cos 45. So you just apply the value. You can get the value of the force in the member AB. Like that, I can get this force as well as this force. Okay. And one more thing, since it is symmetrical, you need not go for this or this side. This side also. What forces are getting, the same value will be reflected. Okay. So here FCD also equal to FAB as well as FAF, that is FDE, that is equal to the thing. So like that you have to approach each and every joint. After finding all the things with respect to how to choose the joint, you find then you can go for the joint B. In joint B, how can you draw? So since it is B now, so here one member, take actually it is hand side. So from B to C, this is FBC, this is close left FB A, then vertical. Okay, this is B to F. And what of this force? Does to be taken account at joint B? You should not take, because this 50 kN directly acting at a point F, but it is not directly associated point the joint B. So when you are taking joint F only, the 50 kN will be added, but the joint B, this 50 kN will not be coming into picture. Okay. So only these three things. Out of this, you should know FAB, that is equal to FBA, even the inversion. You should not take if it is positive, it is negative. Not like that. Both are same only. Okay. So I know this value. One is these two unknowns. Only two unknowns. So like that you can use the area sum of all vertical forces equal to 0, sum of all horizontal forces equal to 0. Like that you can apply. We can get the two equations, two unknowns. You can definitely find a solution. So accordingly, just find all the things. After finding all the numbers, finally just have a table. You can construct a table like members, then force in kilonewton, then you can have the nature of force. Like that you can have a table column. Okay. So find just all the numbers like that, AB, AF, then AB, AF, then BF. So like that you can, up to 9 numbers you are having, 9 numbers you just draw, and what is the force you are getting, just draw this. Okay. Even it is positive or negative. If it is positive, you just put as this tensile. If it is negative, means you put as compressive. But if you are putting compressive means you need not to put the negative signature. Instead of negative signature, just apply here. So here all the numbers will be taken as positive, but what values you are getting, if it is negative means put as negative. That is compressive. Here just place of negative, you put here compressive. That's all. Okay, so that's the way we have to approach on the given perfectness to find the integral values. Thank you for this watching this. Thank you.